Frol, thanks again for taking the time to walk us through the RPC API, and this time from the perspective of the Near Explorer. So I think what we've agreed is we're going to talk about how do we build up this interface of Near Explorer, actually, and you'll give us a tour of this, kind of sweeping through the different data that we see, where it's coming from, to help us make sense of how we're using the RPC API to produce this interface here.
Yeah, sure, no problem. We have, if you open the website, you immediately greeted with this nice page with the dashboard and the search and main bar. Let's go from the top to the bottom just to understand better what are the tools that you can use here. Here we have the network selection. Currently the Explorer is deployed for mainnet and testnet. And whenever you switch, you just select the network, and their interface is the same. It is just the data that is different based on the network selected. On the right, you have more deep down breakdown into different pages that you could be interested in. Blocks and transactions are natural to Near protocol. Accounts is aggregate about like what are the accounts that essentially are currently active or deleted, and the nodes is the page where you would navigate and see more about the network itself, about the archival nodes, validated nodes, other types of services that are also in the peer-to-peer network of Near. So keeping going on the on this main page, you can see that the search is the main part of the page, and that's on purpose. It's very hard to navigate and find to a specific block or specific transaction in the list. It's much better if you have your account ID or a transaction that you want to explore. You just dump it here, click search, and you're there exploring it. So search is a very core feature, and we encourage people to use it. Over there, it's just a lot of nice graphs and overall stats about the state of the network. Let's go one by one here. So the nodes is essentially representing the health of the network itself. It's very important to have as many validating nodes as possible. They are ensuring the security of the data, and that's why it's great that we have so many of them right now. Online nodes, it's all those validating nodes plus those who are using near core network, near core software to essentially get access to the data. One of the examples, like a few of the examples, would be JSON RPC nodes. They are not like validating nodes does not expose JSON RPC to the public just for security reasons. So instead, what is suggested is to always have RPC nodes in front of your validating node, and in other instances would be archival nodes, which keep track of all the history from very beginning of the network, from Genesis. Also, another example is indexer nodes, which one of them is used for Explorer itself. So a lot of them are here. We will open up them once we cover the rest of the page. So
sorry,
yeah,
so just to summarize what I heard you say there, because this wasn't obvious to me when we first talked about it. So there's 60 validating nodes, and best practice is each one of these 60 validating nodes should also have an RPC node sitting in front of it. So that's 120 of the 186 right there, if people are doing what we're asking them to do, right?
Yep.
Then there's the balance of 60, 65, 66 other nodes. That these are indexing nodes including, these are the kinds of nodes that are listening to the network and letting us query it, maybe using a database or something. And then archival nodes are like an indexing node, but it's not for querying purposes, it's just for archival purposes. So the nature of what the node is doing. Yeah, it's a backup node. And are those basically the three four classes: validating nodes that are actively maintaining security and integrity of the network, RPC nodes that are sitting right in front of them by recommendation, indexing nodes, and archival nodes? Or are there any other nodes that are running on the network?
Not that I'm aware of, but they are not limited to these kind of usage. So it's up to, so anybody could modify near core source code and build some sort of tooling on top.
There could be other nodes that are registering here, listening to the network, conforming to the.
If you need to clarify to classify them, I guess these four are the majority of all.
Thank you.
Sure. Blocks is in core nature of any blockchain. We produce block every second, and here is just a simple stat that exposing us to what is the latest block height right now, and whether the network is doing fine. So, and usually you would see numbers are almost identical all the time here. Next, the transactions section is quite interesting in terms of to understand how the network is used, because blocks are produced no matter what, but the transactions essentially represent how the network is used by the end users or other entities. It would be programmatic use. Sometimes it's just ping or Oracle requests to the network. Sometimes they are transfers. So all kinds of transactions are floating in the system. So here the latest 24 hours total, and also 14-day history. We exclude today from the history just because it would be always a drop here. Doesn't make sense to display it. It's useless. And gas prices here is essentially to represent what is the current price to pay for gas on the network. Make sure that you see that it's in teragas metric, so it means it's a tera prefix here. But overall,
we have an article in the documentation that talks about thinking in gas, what this number means, why we say teragas. It's a little bit easier to reason about than some of the large numbers that we're talking about. You just use the prefix teragas and it tells you everything you need to know. I'm surprised to see gas price kind of featured so prominently like this, but I think it's because of the way that we price gas. It actually fluctuates, doesn't it?
It does not right now. It will eventually with the greater load of the network. Right now it's constant, and actually I'm considering to replace it with average transaction fee, which makes more sense to the end users after all. And it just hasn't been done yet. That's the only reason. I also agree it's not the best metric to be so prominently exposed. But,
I mean,
it's wanted to mention that it's still useful.
Yeah, sure, it's fine. But I have another question about this. How do we know what the capacity of the network is? So we see here 10,500 transactions in the last 24 hours. Are we close to capacity? Are we nowhere near capacity? Is there
we are not even near to the capacity. If we open the blocks, you can see the number of transactions in a block. You can see that rarely you can see one transaction, sometimes two. In my experience, on mainnet, I only observed 10 transactions in a single block. We have a special network deployed just for benchmarking, and we could reach 5K of 1K transaction on a single shard. And
It depends on the transaction, obviously. So maybe you're talking about
a
transfer transaction.
Right? That's right. But with the number of shards, it could be linearly scaled, and here we are very far from like any capacity problem right now, and that's why we essentially take it with caution to release more shards. We currently run only a single shard network on mainnet. It's stable, it's well tested, and we don't expect any unknowns. Whereas the sharding is a bit complex thing, and it needs to be more thoroughly tested. And I know that the core team is currently making sure that it's solid and stable, and it's a very important part of future development.
Let's talk a little bit about how this data is getting rendered into the interface here. So, can we go back to the homepage, just the main kind of view of this aggregate? So, just to get an idea, the search bar is using the indexing service, right? Because we have the historical data there, and in fact, a lot of this data that we saw maybe in the other page as well is coming from the indexing service. So the search bar, when you search this, you're actually searching a Postgres database that the indexing service is filling with data as it's listening, and so all that makes sense. And can you tell me a little bit about some of these other numbers? Like, where are you getting the number of nodes online? Where are you getting the number of validators? Those I think should be available in the RPC API, right?
Yeah, that number is available in RPC and API. You can query validators status and
the detailed validator status.
Here, yeah, detailed validator status. You will be returned with current validator list, and if you count the number of these records, you will get the number 60. If you open the page, you will see the same list essentially displayed here, rendered with all the detailed information, how many blocks they have produced, how many blocks they are expected to have been produced. All of that is here. How much
so this is a presentation of the response from calling that method.
Exactly.
Okay, so that explains the 60 validating, new upcoming nodes. That's the data returned by the method. Where's 186 coming from?
Yeah, so every node optionally reporting telemetry to Explore. We've decided to make it optional. We also decided to make it the reporting to Explorer explicitly. So this number could be even potentially, it could be 0 while we have 60 validators. Why? Because validators may choose to opt out of the telemetry, and that's the reason. Then
so there's at least
the nodes are pushing the data to you.
Yeah, the nodes are telling us that they're online. So we know there's at least 186 nodes online. There may be many more, right? And so that's being reported to what exactly? To some other endpoint that Explorer exposes, or
something like explorer.near.org/telemetry.
Something like that, and they're just communicating against that, saying I'm here.
They're just reporting their version, their agent, their latest block, and all the rest info, and we just record when we heard from them and update this in our database in Explorer.
Got it. And then the 60 proposal nodes is coming from the detailed validator RPC endpoint also, as well, right? That's like another collection below the current validators. There's like the upcoming proposals, probably, right?
Yep. Current proposals, over here. So.
Okay, so that's how we're getting 60, 186. So at least 186 online, maybe more, 60. And then what's the nodes map here?
It's essentially a representation of where the nodes are located on the map.
How can you do that? Where's that information coming from?
When the online nodes report to us, we can
part of the telemetry payload.
Where they actually part of the telemetry. So Here you can So essentially, validating nodes, they are not reporting. Not all of them are reporting telemetry. So you could probably find less than 60 here, because if they are not reporting, we couldn't really display them on the map. But online nodes, all 186, we can represent them, though some of them are off sometimes. They're reporting some weird locations or default ones.
Sure.
It's a bug. We should filter them out, but just keep in mind.
Okay.
It's just for representation point of view, like to see how distributed is a network. We currently don't see anybody on this hemisphere, nor in Australia, nor in South America, and Africa is also underrepresented. It's about Africa, I guess it's mostly because the data centers and big factories of computer power are not really built in Africa due to very unstable internet connection and all other reasons. But overall, it's distributed pretty widely across the globe.
Yeah, I mean, this makes sense. So if we go back to the main page, we've now covered, the search nodes. We looked at blocks briefly there. Can we dig into a block? Can we see more detail about a block in this case?
Let me find some block with at least one transaction, so it's not empty.
Sure. Mm-hmm.
So here's block, every block. So blocks are produced, as I said, no matter what, and we can see that the transactions here are in the block listed here. You can query this data through JSON RPC, but we prefer to use our own indexed data anyway, since it's already in our database. Why would we request it again and again from the RPC?
So this whole page is being rendered from the indexing service as well, from the indexing server as well.
Yeah, I believe so. Maybe. Well, what we check is the status. So to understand whether the block is finalized, we essentially have this info. Like we have this block in the database, okay, but we don't know whether it's finalized. To make sure that we display it as finalized, we query the status page, status endpoint on RPC, and see if it's. Not the status. Sorry, I'm querying the blocks.
The block details, maybe.
The block details with the finality final as a parameter, and in response, I will get all.
Maybe with the block ID actually, and then you get the details of this block, right?
Not really. If you query the block ID, you will have this info. All this info is very useful, but it has no information whether the block is finalized, essentially.
I see.
In order to make sure that the block is finalized, we query the final block. We search for the final, and we compare that the height of the final block is greater than the block that we are currently looking at.
I see. Mm-hmm. Okay, and that guarantees it's final, obviously, if that height is greater. Yeah, that makes sense. There's nothing else here being rendered about this block besides the list of transactions, but the response, the payload that comes back from this block details, it's quite extensive. There's a lot going on there. Is there more to talk about there, do you think, or is it out of scope for this conversation?
Well, mostly it's references to next and previous and the state and the various other parts of the network. Timestamp is there. Random value is like internal thing. It's quite an interesting topic by itself, how we deal with random numbers, but it's a very different one. I don't think it's available on Explorer side. Gas price is there. Overall, I wouldn't say that there is something that is missing. We could provide more, advanced features just for the sake of like blockchain developers themselves. But from the user perspective, I guess that's all that is really interesting. Maybe shard and chunks could be exposed, but we decided to ignore the fact that, not ignore, but essentially hide the fact that we are having shards in the system. What we believe is that people mostly care about blocks. Even that is already controversial, whether they really need to know about the blocks and about the transactions themselves. Everything else is an implementation detail. That's why we decided to just skip it and unload the end user from knowing all the neat details about the implementation itself.
Okay, yeah, right on.
Yeah, so, and just to finish up the core concepts, if you go and open the list of transactions page, you can see that there are transactions here in a ordered by the time that they occurred in the network. Again, as we had already covered it, it's all sitting in the database. You can't query it through JSON RPC. So we needed to index this data through going through every single block and save the data in our own database, specifically for Explorer needs. And this way you can answer the question like, give me last 10 transactions here, and here we go. The same goes for whenever when we open a transaction itself, it's all great. It's still under construction here. We are building better UI to represent the internals, so let's not focus on this right now, as it will change in this quarter quite drastically and represent the data better. But what is essentially about the transaction, that the core thing is that every transaction has a signer ID, the signer account ID, and receiver account ID. We estimate its status. It's a bit of a different topic, and let's not focus on it right now. Transaction fee is probably what most of the people might be interested in terms of like estimating how much it costs. Currently, it's quite a small number, even for very complex transactions. If it's just a transfer call, it's even smaller. And deposit value is also quite interesting thing. When you call a function method, sometimes you want to pay for the transaction. Here, the deposit value that represents the attached balance, and all the rest is essentially the internal representation or internal details about the maintenance of the blockchain itself. And what's important here probably is when the transaction happened. Hashes are useful, but you as a user, as a human, did not really make a lot of sense out of them. They mostly are useful for the reference purposes and to make sure that you are looking exactly on the same thing that you expect to look at. If somebody is sending you a link or whatnot. So that's all about the transaction itself. And all the info about the transaction. If you have transaction hash and know the receiver ID, you can look it up through JSON RPC. That's a bit unusual. Usually, transaction hash is enough to look up the transaction in other systems, but given the sharding nature of Near, the transaction will end up on the shard where the account belongs to, and that's why to look up the transaction, you need to specify you need to have some way to specify which shard you need to go to. That's why whenever you look up through JSON RPC, TX status, send, nope, transaction status, here we go. You need to specify the hash and the
what's this hash of, Fro?
It's a hash of the transaction.
Of the body of the transaction itself?
Yep. So whenever you submit a transaction, do we talk about it much? Not really. So when you construct a transaction on your side and sign it, you sign the hash, the transaction hash itself. Your signature confirms that the hash represents the data that is passed next to it. And this hash can be later and throughout the history can be used as a reference to the transaction. This hash is unique and you can always refer to it. So you don't receive this transaction hash as like this identifier from the server. You get it when you have on your side, when you just create the transaction.
So I guess I'm a little bit confused why you would also need to specify the receiver account. I mean, I understand in a sharded environment that maybe center.testnet would be on its own shard, separate from some other account. But you're saying that there's no way to kind of globally search for this transaction hash. You can only search for it on this shard because shards don't know about each other. Actually, they're essentially running in parallel, right? That's how we're getting this ability to scale linearly with shards.
Mm-hmm.
Right?
Mm-hmm. Exactly. So the transaction is I was misleading previously. I was telling you that the transaction ends up on the receiver side. Essentially, it's now the receipts are on the receiver side, but the transaction are always belong to the signer. That's where it starts its journey. To start executing the transaction, you need to first deliver this transaction to the shard where the signer account is stored to verify the signature.
We verify the signature and the budget to actually conduct the transaction, right?
Exactly.
Before we generate the receipts.
Yeah, that's why the transaction is ended up recorded on the signer account chart. And this way we can look it up. So internally, to look it up, we need to specify the sender. But in Explorer, as you can see, you can navigate to the page only providing the transaction hash. It is possible only because we have our own indexing backend, which goes through every single transaction. We store all the transactions in a single database.
Is there some way to change the representation? Random thought. Or have we considered changing the representation of this data that's rendered on this page by appending something like .json to the URL, so that when we request it from the Explorer, it sends back a JSON response of this data as opposed to the rendered HTML? Is there anything like that we've discussed?
We haven't considered that. It's a good feature request. We may consider to build it. I'm a bit, concerned with such features because it may create unnecessary incentive in terms of like people will rely on Explorer too much.
As opposed to having their own indexing service, for example.
Yeah, as opposed to using like the decentralized to comply with decentralized network. And I'm a bit afraid to let people down that way. If Explorer will be so much in like central service for everything, we may just lose the whole app layer just
that
because
makes sense.
Explorer goes down.
Sure.
So. What else? We covered transactions.
I feel like we've covered quite a bit here.
Yeah, we can also go to the last piece, probably is account. Account page is essentially also relies on the data that we collect throughout the history through an indexer. We have transactions. You see, I opened it, the account, and I immediately see the transactions that happened a month ago. It's not possible to go over every single block right now on demand and know the data. It has to be somewhere, and the Explorer indexer is what is helping us to have it. And yeah, we have different types of balances here. I guess we cover them pretty extensively on documentation.
Yeah, we talk about them in the docs for your account balance and your validator stake. Sorry, why does it say native account balance? That seems surprising to me. Why the word native?
Oh yeah, we had a lot of discussions here, and people are getting more and more confused with the balances, and it's no surprise. Even internally, sometimes we refer to the same thing using different terms, and what people tend to want to see whenever they navigate to their own account is their balance. It's only one balance, right? Why do I have several balances? I just want to have one. But naturally, Near is built as a low-level platform with high-level concepts built as like extensions from the application level. So we provide certain tooling, and the balances that are in Near protocol, they are tied to the single account. So these are native Near protocol accounts. This one you can spend it immediately. You can send it to, you can transfer it, you can attach it to function call. This balance is about the balance that you stake as a validator.
I see. So it's we're saying native account balance because you've broken this out into three places, right? So there's the two parts: what you can spend today, what you're staking, and then some aggregate of those two. Those are the three views here. Yeah.
Well, but it's not the aggregate of these two. It's an aggregate of potentially more other accounts which are in the connection. For example, lockup contract is it's a separate account.
I see. So it's the aggregate is the balance that you can control from this account. That's what you're saying.
Yeah. You see, if we open another account which has a lockup account, we display the lockup here. You can navigate there. You can see that it has its own native account balance. What people tend to expect is to have a sum of this value plus this value plus the account could have delegated certain amount to the staking pool. Then it means that we need to sum also the tokens from the staking pool, and it's very complex to pull together. And that's why we tried to do it first on the Explorer side. You could have seen we had quite a lot of balances here. It was very hard to reason about them. People were always confused. They only referred to the one that calls total, but we knew that at some point that total will not be total because more concepts will be introduced, like more lockup contracts or more, like other tokens, NFT tokens, whatnot, could be also attached. That's why we scaled back. Let Explorer only focus on the native thing that we expose through the protocol, and wallet deal with like all the rest. Like you can see here that Nexus account has this amount of tokens. Some of them are reserved. Then the same goes for lockup again. So it's a nice breakdown, a much cleaner representation, and we couldn't make it on this page with the current design. It should have been redesigned anyway to something like this, to have a breakdown which would make sense to the end users after all.
Yeah, so I think I get it. In the end, you're saying from the wallet perspective, you're seeing the account that you control and any other sort of contract level assets that are controlled by this account. So that's the view from the wallet. From the Explorer, you're talking about sort of the native token that this account is holding, and I guess maybe also a lockup account, but there's no room here for multiple lockup accounts.
Yeah.
I don't know if they would show up as a list or something. So it makes sense that we're sort of keeping this focused on the account as some from the account perspective, on the network, an account that engages in transactions and transaction history. That makes sense. You can see this account has sent 72 transactions or signed 72 transactions, maybe received one, something like that. Whereas from the wallet, it's about asset management, what lockup accounts you're connected to and all that sort of stuff. And that makes sense.
Yeah. So that's all what I wanted to cover with the balances. Also, as we might have seen in the docs, when you view account query, you see the balance. So this is a native balance essentially, and this is the staked balance and validator stake balance. These are the two values that we are connecting from JSON RPC response to the Explorer UI. Storage used is here. Storage usage essentially just in bytes, and it's 358 kilobytes, and it's coming from the contract that we deployed on the account. What else?
And that's why we need to maintain 36 near in this account to offset that the through three.
That's what wallet talks
360K there. Yeah.
As you can see, 3580739, and it's exactly the number we see here. So at least currently, we are deploying the new version, which may lower the cost, and it could be just a different number, but right now it's very easy to observe how the storage usage is connected with the minimum balance.
And that's basically reserved until you reduce the storage on the account. Then it's right. Unlocked. You can do whatever you want with it. Yeah, that makes sense. Okay, I feel like we've covered quite a bit here. Is there anything else that we should include in this? I mean, we've kind of gone over all the interfaces, maybe in the Explorer, touched a little bit on the wallet as well.
Yeah, I guess that's all. We don't need to, it could be a very different conversation about various balances and contracts, but overall the Explorer side is, I think, covered pretty extensively.
Nice. Okay, great.
Yeah, thank you.
Thank you.